Hello everybody. Welcome to my presentation for the Universe 2 hackathon. Today I will tell you a bit about coding, testing and deploying smart contracts using ÄProject. A bit about me: I'm full stack developer and team lead at Eternity, and I've been mostly working on developing the ÄProject tool. So, first question comes up: what is a project? A project is a tool to develop and test smart contracts on Eternity. We have a framework. I've just added the documentation link and the repository here, and I will guide you through it separately. Okay, let's start with having a look at how to use a project. The first thing that we have to note is we have a few requirements that we have to have on our system in order to use a project. We have to have Node.js installed in a version that's greater than version 14, and you have to have Docker and Docker Compose installed. There's a few nodes currently on Windows. You have to use the WSL2, so Windows for Linux subsystem version 2, and currently Apple Silicon chips are not supported. We are working on that though. First thing that you will have to do is install ÄProject as a global dependency using npm in order for us to use the tool. Let's first give an overview of how ÄProject works internally. ÄProject uses Docker Compose in order to set up a local node using dev mode and a local Eternity compiler for compilation of your smart contracts. When you did write your smart contract, it uses commonly known Mocha and Chai dependencies for testing JavaScript code. There you will be able to set up a connection to the Eternity node that was installed locally using Docker together with our dev mode plugin in order to deploy and test your smart contracts. This also includes functionality for creating snapshots and rollback. In the default setup of ÄProject, a sample test structure is given that includes all of this functionality, and we will have a look at this in a second. When we go back to the documentation, the first point that we see is project initialization. So what we can do here is use ÄProject to init a new example project. This will create an example smart contract and an example test for us to have as a point of reference. We can also initialize using the --update parameter to update existing projects to the latest ÄProject structure if you have an already existing project and want to update from an old version of ÄProject. The next step that we have to do in the lifecycle of using ÄProject is using ÄProject env. This will spawn up our node and compiler using dev mode using Docker Compose as explained previously. Here's also a few optional parameters where we can specify a specific node and compiler version if we may need that. We can use the --info command to check our currently running node and compiler. Next step we will use is ÄProject test, which executes all tests in the test folder. The tests are written using the assert library from Chai and are being executed using a Mocha. In the documentation I also added references to Mocha and Chai, so if you have no previous experience with those tools, you can look up how they work there. Let's jump into the terminal for a demo. First thing that we have to do is use npm to install the version of ÄProject. Here we have to use the global install option. This will take a second depending on your system. Next thing we can do and check if everything's working, use ÄProject --version. This will give us the latest version. Currently it is at version 4.1.5, which includes the latest fixes. As the next step, we can use init to set up an example project. This will create a local new folder called sample project, initialize the example structure, and install the necessary dependencies. Let's jump into that new folder. And here we can use ÄProject env to set up our testing environment using Docker. This will take a few minutes depending on your internet connection, as it will have to download the latest images from the Docker Hub. Let's use info to check our local environment running. So we can see our sample project compiler, node and proxy are running and healthy, as well as the ports they have exposed if you may need those. Next, we can use a project test to run the included example test. As you can see, this uses Mocker to execute our tests, and our example set and get test works fine. Let's have a look at our example project in an IDE. If you look at the package.json, you can see this is a normal npm project with the dependencies installed that we need. We have as a normal dependency the Eternity SDK that we use for interaction with the Eternity blockchain. We have our ÄProject library helpers, and we just have Chai and Mocker to execute our unit tests. In our contracts folder, we have an example contract. We test using our example tests. So you have a provided sample test structure. In our tests, we use assert from Chai and we import our utils from ÄProject. We also set our reference to our contract source code path. In our before section that runs before executing any of the tests, we will initialize our SDK using our getSDK function from the library utilities. We have our getFilesystem, which initializes included source code that we reference in our smart contract. We have our getContractContent, which reads our contract source code. Then we use the SDK to get an instant of that contract. We deploy our contract, and last but not least, we create a snapshot so we can easily roll back to the first version of our smart contract. Then after each test execution, we use the utility function and the dev mode to roll back to our initially created snapshot. Additionally, you can see two example tests created here. The first test is for our set method of our example smart contract. In our smart contract, we have our state, which is an optional number, int, which is on deployment set to none. We have our test method, which is an entry point, so it can be called from outside, and it is stateful, so it can write to state. We give as an argument our x. We throw an event that can be parsed later, and we use the put method to mutate our state to now be sum x, so a defined number. Additionally, in our sample smart contract, we have a getter function, also an entry point that can be called from external, called get, where we can receive our current state. In our test structure, we first call set. So we set the number 42 using a separate account. This is just done as an example for you to see how you can use the included example accounts. And then we expect our event, setX event, to be thrown with the correct address and the correct amount. And afterwards, we use our contract methods.get function to call the get endpoint, and we expect that our variable that has been set to 42 initially to still be 42. Another test case that we have is if we want to get before we have set any value, we will receive undefined, as our state has not been set yet. Next up, let's show how we can extend our smart contract and add a new test case for that. My goal is to only let the contract creator be able to change the value in our set function. For this, we can use our require in Sophia, and we use contract.creator is call.caller, and if this is not happening, we want to throw an exception, which is only owner can set. So with this, if somebody tries to call a set function, the check is first running. If the creator is the caller of that method, that it works. If any other account is calling the same set function, the call will abort. Now if we go to our terminal, use ÄProject test, we will see our test fails because only owner can set. As here we have our on account set to use a different account than the one the contract has been compiled with. So let's remove this check. Let's remove the setting of the on account. So we use the same account that the contract has been deployed with, and we also adjusted the assert here to use account 0 instead of 1. Let's execute our tests again, and we will see they pass. But of course, we also want to add a check that our condition is true. Let's do the same as above. We create a new constant. Set not creator error is await contract methods set. Let's choose a different number. Let's use 99 and specify on account is await utils dot get default account. We choose first one, and we expect this to throw an error, so we want to catch that to check what was the error.message. So we use e.message. Then we can assert our error to include our only owner can set error message. Let's execute our test again and see if it passes. Everything is fine. So here initially we set the number 42. Then we try to set the number 99 with a different account. This call aborts, thus the number is not set in the state of the smart contract, and when we get our contract state later, it is still 42 as set above. If for some reason we would have a bug in our smart contract logic where this is not correctly aborted, for example, this test case will catch potential errors. After showing how ÄProject works and how we can use it to write and test our smart contracts, let's jump into how we can deploy and interact with our contracts on Eternity testnet or mainnet. We will do this using the AE CLI. I again added here the links to the documentation as well as the repository. Let's jump back to our terminal. First thing we have to do is use npm again to install the AE CLI. First thing we can do here is use the AE CLI now to create a new wallet. For this we will use the account create function, and we give our account the name sample wallet. Here we have to choose our password with which the local wallet is being encrypted for safety of your funds. Of course, this should not be done for production purposes, only for test and interaction, but still we want to keep our private key safe. Our wallet has been created and we can use the account address to receive some testnet funds from the faucet. In the faucet, we have to pass our account address and press the top up button and wait for a second for our funds to be received. Next, we can use the AE CLI to check our account balance. Again, we have to paste our password in order to read it. We have received 5 AE. The denomination shown here is Atto, so the smallest unit of Eternity with 18 zeros in the end. Next thing we want to do is deploy our example smart contract that we have just created. Here we can use the AE CLI contract deploy method. We have to specify our wallet that is to be used and the contract source that we expect to deploy. Again, we have to use our password in order to do the deployment on chain. Here we see our contract has now been deployed to this contract address. Let's copy that for later use. Next thing we want to do is interact with our contract. First, we want to call the set method. For this, we will use the ACLI contract call method. Again, we specify the wallet to be used and the contract source. Then we specify the contract address where the contract is deployed, which we have copied from the above output. Last but not least, we have to set the function that we want to call as well as the arguments we want to pass. The arguments have to be passed as an array of string. Our contract has been called, we receive some debug output, but everything seems to have been fine. Let's use the similar command as previously to get our output. Here we can specify now additionally call static in order to not make a transaction on chain, but to only dry run our execution for our get method, as it does not have to write to the blockchain. And we receive our decoded return value, which is 1 as expected. Thanks for your attention. This was how we can use a project to write and test our smart contracts and use the AE CLI to deploy and interact with our smart contracts on chain.